So now that we've constructed a simple MO diagram using just S atomic orbitals, I'd like to talk about what happens when we bring p orbitals in to build these molecular orbitals as well. Remember, we're taking a combination of atomic orbitals to try to build a picture of molecular orbitals. And for this class, it's just intro chemistry. We're only going to really look at s and p orbital contributions into our molecular orbitals and save d orbitals for another class. So let's look at the two different ways we can combine these. So we're going to think about this again, remember, as our orbitals coming together in a constructive and destructive interference way. So we're going to think about these p orbitals combining along all three of the axes that the p orbitals line up on. So here we are looking at the x-axis. So let me draw an axis for us just for reference. So I guess this one's going to be x, y, and z, I hope. All right. So when these come together head on, they're going to have overlap right here if there's constructive interference, right? And so this part right here is going to get really large. It's still going to have these out of phase areas that aren't overlapping with one another, but they'll be small compared to those overlapping lobes of the p orbitals. And that creates, because they're coming head on, that creates a sigma style bond. And so this will be a sigma 2p bonding orbital. And then the anti-bonding version of this is if they're destructively interfering, they're not going to overlap and build something bigger. They're going to cancel each other out. And so what we see is the creation of a large node in between them. And then they're out of phase on either side of that node. They're two different phases. And that creates our sigma star 2p anti-bonding orbital. So here's one of our p bonding and anti-bonding orbitals that we can create. Now, the next two are going to come parallel to one another rather than head on. And so we can see here's 2z. So this is, again, remember, we've got our axis. And so when these come together, if in a bonding way, or sorry, in a constructive interference, when these wave functions overlap constructively, the two lobes on either side of the node of the p orbital are going to overlap and get bigger. They're going to amplify each other. And so we get a bonding pattern for our molecular bonding orbital that looks like kind of a hot dog bun. And this looks a lot like the valence bond hybridized orbital for pi, right? So in this case, it still keeps the same node that it has here. Like that node doesn't go away because we're bringing these together. And this will be our pi 2p bonding orbital, MO. And it's a pi type bond because it has a node. The sigma bonds don't have a node in between them unless it's an anti-bonding orbital. Now, when we look at the way these would destructively interfere, it's kind of like they're coming at each other out of phase. So another way to think about this is like they're combining this way, out of phase with one another. And so they're going to destructively interfere and create this large node in between them, on top of the node that already exists within each of the p orbitals, right? So now we have two nodes. And these are going to be out of phase on either side of that node. And this will be the anti-bonding orbital, and it's a pi style bonding, again, because of that planar node down the middle. And so it'll be a pi star 2p. Now, the last one's going to look very familiar now. Now we're looking at 2py. So these are coming together in the y plane. So here's the y plane. And they're coming again parallel, just like the z ones we just looked at. And so when these are going to combine constructively and destructively, we're going to see that constructive interference where it just looks like a hot dog. We still have the original node in place between the two phases of the p orbital. And so this will be our bonding MO. And it's a pi style one, so it's pi 2p still. And then our anti-bonding one creates that new node in between them as these come together out of phase and destructively interfere. And so you have these two nodes here. So it's still pi, but now it's pi anti-bonding, so it's pi star 2p. And those are how our p orbitals are going to combine using this linear combination of atomic orbitals estimation for molecular orbitals.